We have some huge updates. OpenAI just finished pre-training a new base model for GPT-6 Astra, and it is massive. Not only this, OpenAI also launched its own hardware chip, which has beaten Nvidia hands down. And the powerful, mysterious model that ate the internet for 6 days has been officially released as GLM 5.3 Flash. As we can see, all these updates have a profound impact on our day-to-day work. So without any delay, let's get straight into the details. Starting with the biggest update of this week, OpenAI's new base model. Well, a few weeks back, the rumor mill was fixated on a codename called Doug, described as OpenAI's largest pre-training run to date, expected to serve as the base model for Astra. Well, Doug already has a successor now, and it showed up faster than almost anyone expected. The scoop came from an X account called SynthwaveEd, and it spread within hours. OpenAI has reportedly finished pre-training a new model codenamed Bell. That single post pulled in over 4,000 likes. Wall Street Engine picked it up and ran the same numbers. Bell is described as a giant pre-trained model, north of 10 trillion total parameters, putting it in a similar size class to GPT 4.5. The reporting says OpenAI intends Bell to serve as a post-GPT-6 base model, with one leak going as far as calling it a candidate for the world's first AGI threshold system once further training is layered on top. To be clear about the chain here, Doug is the base underneath Astra and GPT-6. Bell comes after that as the base for whatever ships once GPT-6 is already out the door. We have more on that. But now let's move to a bigger update perhaps, as OpenAI just launched their own hardware chip, causing a real havoc in the entire tech industry. Here it is.
This is really interesting, taking everyone off guard. Well, OpenAI have launched their own hardware chip, which has beaten Nvidia hands down. And this did not happen quietly. OpenAI walked straight onto the stage at Hot Chips, one of the biggest hardware conferences of the year, and put real numbers up in front of the entire industry. The chip is called Jalapeno, built in partnership with Broadcom, and it is OpenAI's first custom inference ASIC, meaning a chip designed to do exactly one job well, running an already trained AI model as fast and as efficiently as possible. The headline numbers, according to OpenAI's own Hot Chips presentation and independently tested by SemiAnalysis, show Jalapeno beating NVIDIA's GB200 and GB300 Blackwell systems across 3 different open models. Those are GPT-OS S120B and DeepSeek R1670B plus Kimi K2.51T. On performance per watt, Jalapeno posted somewhere between 1.5 and 1.9 times NVIDIA's numbers. On latency, it cut end-to-end response time by 1.7 to 3.6 times. At a concurrency of 1, meaning a single user hitting the chip with nothing else competing for its attention, Jalapeno hit more than 700 tokens per second, which one analysis put at over 50 times the throughput of NVIDIA's GB200 at that same narrow scenario. PowerDraw tells a similar story. One source puts Jalapeno's sustained power envelope at 550 watts, while another cites 700 watts per compute die specifically. Either way, that is well below the 900 to 1150 watts NVIDIA's upcoming Vera Rubin platform is expected to need. On raw peak compute though, Jalapeno still trails what NVIDIA is promising from Vera Rubin, 13.4 petaflops of NXFP4 versus 17.5 petaflops of NVFP4. So this is not a chip that wins on every single axis. It wins specifically on the efficiency metrics that matter most once a model is actually deployed and serving real users. The timeline here is the part that stopped me. OpenAI says it started designing this chip in mid-2024 and had working silicon by November 2025. That is roughly 16 months from concept to a working chip, in an industry where NVIDIA has had 2 full decades to build out CUDA, its programming platform, and the surrounding ecosystem of tools, libraries, and trained engineers that together form what is widely called the CUDA moat. Here is the part that genuinely surprised me watching the deep dive on this. OpenAI is not trying to make Jalapeno's low-level programming friendly for humans at all. They built their own kernel language for it called Gluon, and it is intentionally sparse and manual, closer to assembly than to a normal programming language. The reasoning is that a human-friendly language is not actually the point anymore. What you want instead is a small, sharp, tedious language paired with an AI model that is more than happy to write in it. That AI model is OpenAI's own codex. When engineers first tried running the DeepSeek R1 model on Jalapeno, the chip had no internal kernel for DeepSeek's unusual multi-head latent attention setup, since OpenAI's own models never needed that particular architecture. Codex reportedly wrote a functional, efficient kernel for it very quickly, some running to 3,000 lines, backed by correctness checks and a custom sanitizer, closing a gap that would normally take specialist human engineers a long time to fill by hand. Semi-Analysis, who actually got hands-on access to test the chip themselves rather than just taking OpenAI's word for it, called this a weird twist of fate. OpenAI's own models, the ones currently running on NVIDIA GPUs, were used to help design and program a chip that now poses a real threat to the very CUDA moat those models were trained on top of. That is the recursive self-improvement loop people have been talking about, playing out in actual silicon. Reactions on X ranged from genuine excitement to pointed skepticism, and I want to give you both sides before we move on. One widely shared thread bluntly noted that OpenAI announced this chip 28 hours before NVIDIA's own earnings report, and NVIDIA's stock went up 2% anyway. And on YouTube, one commenter summed up the strange position NVIDIA is actually in. It is confusing. NVIDIA invests billions in OpenAI, then OpenAI makes chips that reduces the need for NVIDIA chips. Is this a sensible play by NVIDIA? Now let us pivot from a chip that shipped with real numbers attached to a model that shipped with no name at all. Let's have a look.
As you move to the most crucial portion of the video, do tell me which AI is your absolute favorite. Plus, hit that like button and press that lonely subscribe button as well.
For 6 days, the most talked about AI model on the internet had no name, no company behind it, and no price tag. It just appeared on August 20th across OpenRouter, OpenCode, Klein, and a handful of other developer platforms simultaneously, with nothing attached but a random code name, Ox Alpha. By the time G.O.T finally confirmed what it was, Ox Alpha had reportedly processed more than 20 trillion tokens in those 6 days, which OpenRouter says makes it the single biggest model they have ever hosted. So, GLM 5.3 Flash comes from G.O.T, the Chinese lab also known as GPU, and it carries 320 billion total parameters with only 18 billion active per token, built on a mixture of experts architecture with hybrid sparse and linear attention. Compared to the GLM 4.5 generation, that is a similar total parameter count, but the active parameters got roughly halved, from 32 billion down to 18, and the layer count got roughly halved too, from 92 down to 45. It handles text and images natively, plus video, making it the first model in the entire GLM5 family built from the ground up to be natively multimodal. It supports a full 1 million token context window and ships under an MIT license with open weights on Hugging Face. On pricing, G.AI launched it at a discount running through early September at 7.5 cents per million input tokens and 25 cents per million output tokens. Compare that to GLM 5.3 itself, which runs $1.40 input and $4.40 output, and you can see why the cost angle became as much of a headline as the benchmark scores. On official numbers, GLM 5.3 Flash posted 63.4 on DeepSuite and 84.3 on Terminal Bench 2.1. It also edged out Claude Opus 4.8 on G.AI's own code bench, 29.5 versus 29.0, while using roughly 40% as many output tokens to get there. Now here is where the story gets really interesting. One post joking, "What if Ox Alpha was the friends we made along the way?" pulled in 1.3 million views on its own. This was not a quiet stealth launch. This was the community collectively losing its mind trying to solve a mystery in real time. Developer Ben Davis ran it through a 10-task sample of the DeepSuite coding benchmark and posted the results plainly. GPT 5.6 Sol scored 52% and Claude Fable 5 scored 65%. Ox Alpha topped both of them at 80%. Stripe CEO Patrick Collison, after trying it himself, called it very impressive. AI analyst Andrew Curran opened a thread just for guesses and test results, saying people seem less sure of anything about where it actually came from. Here is where the community conversation actually gets interesting, because it stopped being purely about who wins on a leaderboard. One widely shared take from a writer going by InProgrammer argued that GLM 5.3 didn't beat Claude or GPT, it changed what we compare. The shift in that framing is away from raw coding quality and toward cost and control. It is also about whether a model can reliably finish an entire software task rather than just write good code in isolation. That framing shows up constantly in how people describe actually using it. Developers testing it for long context coding agents and repository-wide work kept coming back to the same point, that near Fable 5 quality at a fraction of the price changes the math on running agents all day rather than for a single quick task. Not every comparison went GLM's way though. Reporting on the broader benchmark spread noted that GPT 5.6 Sol still holds an edge as the better generalist coder. Claude Fable 5 and GPT 5.6 Sol both remain ahead on select coding and terminal evaluations, plus most offensive security tests. Where GLM 5.3 pulled ahead was specifically on cost and deployability, and on defensive security tasks. That is not a clean sweep across the board. Some users pushed back even harder, comparing GLM 5.3 Flash unfavorably against the full-size GLM 5.3 and finding it noticeably weaker on certain benchmark categories. A reminder that Flash in the name means a real trade-off, not a free lunch. So to sum up the community read, people are using GLM 5.3 Flash for long-horizon coding agents and multimodal interface work, with cross-file refactoring coming up constantly as well. And they are comparing it to Claude and GPT 5.6, less on a single benchmark number, and more on whether it can run all day for a fraction of the cost. And now it's time for some honest thoughts on these updates, because a few of these stories are stronger evidence than others, and I want to be clear about which is which. Here are my honest thoughts on these updates. On Bell, I want to be direct about the sourcing. Every detail here, from the 10 trillion parameter figure to the AGI threshold framing, traces back to a cluster of X posts that all surfaced within a few hours of each other. Most of them cite an account called Synthwaved as the original source. OpenAI has not confirmed the existence of Doug or Bell in any official capacity. Treat this entire section as an unverified leak chain, not a confirmed roadmap. On the Jalapeno chip, the headline numbers are genuinely stronger evidence than most tech announcements, since Semi-Analysis actually ran their own tests rather than repeating OpenAI's press release. Even so, Semi-Analysis was explicit that they have not run their full preferred test suite yet, and their tests were verified in person but still limited in scope. It is also worth being precise about the DeepSeek R1 results specifically. The 700 plus tokens per second per user figure was measured before Codex had written a proper kernel for DeepSeek's unusual attention architecture, and separately, one widely shared video was specifically titled to correct an inflated claim floating around that Jalapeno beat Nvidia by 104 times, which is not what the actual data shows once you look past the single best case scenario. And do not skip past the detail that Nvidia's stock rose 2% the day this all broke, right before Nvidia's own earnings. The market, at least in that moment, did not treat this as an existential threat. On GLM 5.3 Flash, the Smash's Claude framing in this title is fair on cost and on several specific evaluations, but it is not a clean win across every coding and security benchmark. Multiple reports are explicit that GPT 5.6 Sol still leads as the better generalist coder on some tests, and some users found the Flash variant noticeably weaker than the full GLM 5.3 on certain benchmarks. Ben Davis's viral 80% deep SWE score also came from a small 10-task sample, and it runs higher than Z.AI's own official full benchmark figure of 63.4%. Both numbers are real, they are just measuring different things. So, what is your opinion on these updates? Do share in the comments. Subscribe for more AI news and updates. I'll see you in the next one.